Okay, wanted to go through this integral that we did in class today and kind of run through all the work that's involved here. So we started out with the tangent squared x, secant cubed x dx. We went about a couple of different ways of trying to tackle it and realized that one of our first approaches here was probably the most efficient way. So we use a Pythagorean identity to go ahead and take your tangent squared x there and turn it into secant squared x minus 1 here, and then distribute the secant cubed through the parentheses to get these two terms, and then split that into two integrals. So what I'm going to do here is I'm going to call this one integral A, this one's integral B. So first let me figure out what integral A is. So what we do is we take secant to the fifth x dx, we peel secant squared off of that, and then we go ahead and use integration by parts. I'm going to be choosing to have my dv here, and then going to choose to have my u to be my secant cubed right there. And then we go ahead and carry through with the integration by parts. The antiderivative of secant squared x dx is tangent x, and then the derivative of secant cubed requires chain rule. So the 3 comes out in front, then secant squared x, then the derivative of secant, which is secant x tangent x dx. So then I come up over here and I've got my ultraviolet right here minus my voodoo. Negative 3 came out because of the 3, and then of course in integration by parts it's minus. So that gives me this new integral here. I go ahead and I switch my tangent squared again over to secant squared x minus 1, and I brought my left side down here. Here's my ultraviolet, it's right there. And then when I distribute my secant cubed through, I get a secant to the fifth minus secant cubed. So now I take my negative 3 and I distribute it through, negative 3 here, get this. Splitting this into two integrals, this will become a plus 3. There's my other integral. And I notice that now I have negative 3 of these secant to the fifths, and then that's identical to what I have on the left side. So I actually add the 3 secant to the fifth x integrals to both sides. That will give me 4 of them on the left side, and it's gone away on the right side. So what I'm left with is the secant cubed x tangent x here, and then I'm left with this 3 times integral secant cubed x dx. Then I divide both sides by 4 or multiply both sides by 1/4. So I get 1/4 of this, and then 1/4 times 3 is 3/4, and I still have this integral here. Now this integral is actually the same as the integral that I had up here. So I'm going to actually need this. I'm going to need to actually go figure out what this is. So I'm going to do that on the next page, and then I'm going to come back and put that answer here. So on my next page, I work on the secant cubed x dx. So again, integration by parts, I peel off a secant squared. I let that be my dv. I let the secant over here by itself be my u. Do my derivative here, do my antiderivative. Here's ultraviolet minus voodoo. And then again, switching my tangent squared x over to a secant squared x minus 1. Distributing my secant through, I get this. Distributing the negative through and making two integrals. I realize I've got secant cubed on both sides of the equation again. Add a secant cubed on both sides. That gives me 2 of them. Over here I've got my ultraviolet, and then I have this secant x that was still here. The antiderivative of secant x dx is going to be this. That was a formula. And then I divide both sides by 2 to get this. So my secant cubed x dx here, this integral, turns out to be this. Now take that back, and let's put it back into that other page here. So I had my 3/4 in front, then everything I just did is right here, and I distribute my 3/4 through to both of these terms, and I get this. So this is just this first integral right here. Then I've got to subtract from that this integral, which we just found on the previous or on that page that I just showed you. So here's where we are. We've got the secant to the fifth x dx, which is all of this. I've written that all down right here, minus secant cubed x dx, which we found on that other page. It's right here. I put it in brackets so we can distribute the negative through. I noticed that the blues here are like terms. They both have secant x tangent x. So if I have positive 3/8 of these, I take away half. That leaves me with negative 1/8. Same thing here. I have 3/8 of these natural logs. Take away half of that same natural log. I'm left with negative 1/8. So this is my final answer right here. Now, I went ahead and checked it using the reduction formula. Now, I didn't write the reduction formula down here, but if you do the reduction formula on this, here's what the reduction formula gives you right here, this. Then this integral right here is a formula. So secant cubed becomes this. And then I have the reduction formula on secant to the fifth, which, where did I put that? Oh, there it is. I accidentally forgot to put the secant. Here's the reduction formula on secant to the fifth right here. So if I take this integral and I subtract this integral right here, it's basically taking this entire expression and subtracting from it this expression. So I would get this piece, which is here, minus, now you have to keep in mind right here what this is. This is, what I did was I said this is 3/4 of this, and then right here I'm going to be taking away one of these. So that'll leave me with negative 1/4 of those. It's a little tricky, but that's what I did. So I've got this piece here, that was that, then the negative 1/4, and then using the reduction formula here I get this. So anyways, it's just a check. This matches up with what we just got. I know that's a little confusing because I just did it for my own sake to check. But check it for yourself. Using the reduction formula, you get the same answer. So I hope that kind of clears it up. What I'm expecting to see on a quiz, if you do this for bonus, would be all this work here that I did. And I'm posting this video without telling you, so maybe you'll stumble upon it. All right, hope that helps. Hope that clarifies what happened in class today.